So, a few days ago I made a video on where I was comparing the Cumana, the Cumulus and the Loci, and the Cumana was much slower. And I said that it may have been caused by the Interleave. And, well, I probably should explain what the Interleave is. So, in our case, we're talking about a floppy disk, 3-inch floppies that quite a few of you probably have seen as the Amstrad, the CPC version from Amsoft. And contrary to a CD or a LP where data is just continuously rotating, on a floppy things are organized with sectors, as you can see here. Not sure it's very visible. Here we have the example with 16 sectors. In my project I'm using 70s for performance reasons, for storage reasons. And here is basically what would be an interleave of 1. So you can see sector 1, sector 2, sector 3, sector 4, sector 5, 6, etc. And we have our 16 sectors like that. Except it does not work in practice on a very slow machine like the Oric. With the 1 MHz 6502, we simply do not have enough processing power to read the sector and process it, especially in the case of my game where everything is compressed. So you need some time between. So here that would be what Interleave 2 is. First sector, second sector, third sector, fourth sector, 5, 6, 7, 8. Basically, one sector, one empty space, second sector, empty space, etc. So that gives you twice the amount of time to load data compared to Interleave 1. Logically, that would be what Interleave 3 is. First sector, 1, 2, third, second sector, 1, 2, third sector, 1, 2, etc. Even more time. But obviously it means that it takes potentially even longer to read all the sectors if you were able to read them fast enough. And that is what will be Interleave 6B. 1, 2, 3, 4, 5, 6, sector 2, 1, 2, 3, 4, 5, 6, sector 3, 1, 2, 3, 4, 5, 6, sector 4, etc. Interleave is something that you define at format time. So, as it happens, my tool, the floppy builder, is generating the floppy entirely, and it has a support for Interleave parameter, but by default it's using Interleave 1. So I did a test. What would be the result on the Cumana if I was testing every single version of Interleave from 1 to 16? Interleave 17 being basically back to Interleave 1. And here you can see the results. So what you can see here are 16 video captures, each one made on the exact same Oric Atmos connected to a Cumana Reborn device, and each running a different version of the game, which is basically identical except the floppy reader parameter for Interleave has been set from 1 to 16. And I've been trying, so it's manual test, but I've been trying to basically boot them, press the record at the boot time, and then immediately press R to start the discrete test. So I realized that the other day I did not explain why the numbers are. So on the left, the 96, 84, 71, 36, 68, 11, 22, 50, and 6 is just the ID of the image file. And on my system, they are linear in memory, on disk, which means by interleaving the number like that, I'm kind of forcing the system to read the disk, the files on the disk out of order, which is making the performance worse. In the game itself, I've been trying to read them locally to avoid too much movement of the disk head. Min and max are related to the path going from 1 to 10. It's basically the shortest and the quickest and the longest recording time for each of the images. The number on the column after, it's the delta between max and min, just to see if things were very stable or not. And the time in second is the max value, but converted in seconds instead of clock cycles. So it's easier. And as you can see on Interleave 1, we are at pass 5 out of 10, while on Interleave 6 we are already at pass 9 out of 10, It's like almost twice as fast. And you can see by looking at some of the pictures that some are loading the picture much faster than others. So I think we are at the end soon. Yeah, so we can see that the Interleave 6 has been the fastest. It's done the 10 pass, while the Interleave 1 is still at 6. Then we have Interleave 7 and 4, which finished almost at the same time. Interleave 5 just finished. Who's going to be the next one? Interleave 10 on 11 on 9. At this point we are in recording something error. Interleave 8 is done. I guess you can see a pattern. The recording in the center are already done, but the one at the top and the bottom are still going on. 13 is done. Who's going to be the next one? It's almost like you're looking at a horse race. Interleave 14. Come on, you can do it. Interleave 3. With 4 remaining. Interleave 15. 3 remain. 16 is gone. 1 is gone. And the slowest is Interleave 2, which is still going on. And I believe that's the last picture. And there is the result. So, what does it look like in terms of graph? Well, you can see that there is a sweet spot with Interleave from 4 to 7, and then lower than 4 and higher than 8, it's start going up significantly. So it's kind of difficult to say exactly what is causing the thing. It's a combination about processing time when reading the sectors, the way it's stored, how long it takes to seek from a track to another one, and in my case, the files are stored using the compression, which means there is some time required to get the data out. If it was loading directly the sector and copying in memory directly without any processing, then I would probably have different results in terms of interleaving. So it's not a one-size-fits-all. It's probably something you need to check on your own project. But yeah, I hope you learned something, that it was interesting. I may spend some more time doing this type of thing on the micro disk, on an actual physical floppy, because the Cumana Reborn is still somewhat a piece of hardware using a Gotek, so it may not be 100% identical to a 3-inch drive. But yeah, so that's it for today. Bye bye.